Okay, kiddos. So you just watched the beginning of biochemistry, which was all the introductory stuff, like knowing the difference between here I come with it, monomer and a polymer, knowing the difference between how we link up to make these polymers versus how we break them down, dehydration, synthesis, and hydrolysis, what a molecular formula is, what a structural formula is. And so we're going into our first category of biomolecules, which are the carbs, one of my favorites. Okay, the elements involved in carbs, I always say they're the CHO, C-H-O, carbon, hydrogen, oxygen. And it's always in a 1 to 2 to 1 ratio. That's why they call it carbohydrates. Hydrate stands for water. Here's the water part of it. And a carbon of hydrate, a hydrate of carbon. That's it. What is the purpose for carbohydrates? Carbohydrates, why do we eat carbs? Okay, and everybody always thinks carbs make you fat. No, carbs don't make you fat. What makes you fat is when you don't burn those carbs off after eating a lot of them. But the purpose for carbs is really energy, and it is your first energy source. Your first energy source. I like to think of carbs as like the paper, twigs, and dry logs you would put on a fire. Okay, remember that a little later. The paper, twigs, and dry logs that you put on a fire. The cell parts that are involved with carbohydrates, well, you have cell parts that make carbs, which are only found in plants, by the way. They are the chloroplasts. They make carbs, okay, or sugars. Sugar is a type of carb, okay, and you'll see how it all fits together if you don't know already. But mitochondria, that's in all organisms, takes those carbs and breaks them down and forms a type of energy that our cells can use. I know you always think the mighty mitochondria, the powerhouse of the cell. Well, they break carbs and make ATP, which is actually cellular energy. It's as if our mitochondria are like this Mr. Fusion thing. Like you put food into your body and Mr. Fusion would change it into a fuel that's useful. Like if you've ever watched Back to the Future, they have in the second and the third one, they have the little Mr. Fusion. They put all this garbage in that runs at 1.21 gigawatts of electricity. And mitochondria is like that. You put food into your body and it changes it into this form called ATP. And later we'll learn more about ATP, exactly what the molecule looks like and all. But right now, let's get back to the carbs. Carbs are the food that you put into your body, and the mitochondria is what breaks that down and gives you your energy. So when we say carbs are your energy source, they sure are. They're going to make your ATP. Okay, next slide. Now, in every category, right, we're always going to talk about, why do I have two of these right here? Sorry about that. I must have printed out two by accident. Okay, we're always going to talk about the elements involved, the purpose, the cell parts involved, and then the monomer form and the polymer form. This diagram here is going to talk about the monomer form. And the monomer form, you'll like this, is the monosaccharide. Mono meaning one, okay? And glucose is an example. And you can see this. See how it's like one ring? It's like those beads. It's just one bead, okay? Monosaccharides, one, all have the formula for the ones that we need to know. They are all C6H12O6. Does this sound familiar? Yeah, that's a molecular formula, and they all have the same molecular formula. Glucose, and also remember galactose and fructose. Dare I show you that sheet from that other video? Glucose, galactose, and fructose. They were all isomers. Okay, they all had C6H12O6, but they had different arrangements. Those are all monosaccharides. They are the simplest form. We call these the simple sugars. These are the simplest of all the sugars. They're only one ring big. I always call them, they're like one bead big. Okay, they are like the paper. If you're having a fire, right, and you throw paper, and you throw paper onto that fire, what's going to happen? It's going to burn up fast. You know how it gets like really bright right away and then it burns away? Well, that's the same thing with sugar in your body. If you eat like candy, it gets in your body and you get like, hyper with sugar, but it burns up fast. And after you're done with the sugar, you kind of have your like sugar downer, afterwards. You're like, I need more sugar, sugar high, sugar low. Okay, simple sugars are like paper in a fire. Okay, they are going to burn up fast in your body. They burn fast. Okay, and these are the sugars. Okay, and yeah, you don't want to eat a lot of those because you get that sugar high and then you get a sugar low after it. You would have to keep eating sugars and keep eating sugars. And of course, if you don't burn them all off, like say you threw a bunch of papers into a fire and then all of a sudden you're like, I got to put out the fire, right? You're not going to stand there and wait. Then you like hose it down. And now you have a bunch of wet paper there. And that's what happens to these sugars if you don't burn them off in your body. They're just going to sit there like wet paper in your body. Okay. All right. And the other form that isn't really a monomer, it's a dimer, okay, are the disaccharides, okay, because they have like two of those beads. They're like this, okay. So monosaccharides and disaccharides, these are still sugars. So we'll still call them, like up here, we said these were the simplest of sugars. These are still sugars. Okay, and they still burn like paper, burn quickly, we'll say burn quickly, okay. And yeah, you're going to get a sugar high from these, but because they're disaccharides, let's figure out what their molecular formula would be. Now, if I said 1 plus 1 equals 2, right? Because mono plus mono would equal di or 2, right? Well, then we should take a monosaccharide formula and we should be able to add it together to get a disaccharide formula. So let's try it. C6H12O6 plus another C6H12O6 should give us C12H24O12. And you would think that's the formula for a disaccharide. Well, guess what? It's not. The formula for a disaccharide is C12H22O11. What happened? Okay, now if you look at what happened here, you'll notice that there's two less hydrogens, right? So it seemed like two hydrogens were removed from that formula, but also one oxygen. Oh my gosh, some of you are already figuring this out. Because if you remember from the first unit, dehydration synthesis was when you took one monomer and another monomer, and when you linked them together, boom, you had to remove a water. Well, that's what had to happen here. You take one monomer, so this is mono plus mono, should make di, but you have to subtract that water to connect them. This is your disaccharide here, okay? Now, disaccharides, just like monosaccharides, all have the formula C12H22O11, but they differ in their shape. In fact, there's 3 disaccharides that are quite popular out there. Okay, one you've probably used. Let me set these aside, these beads aside, and move this up a little bit so we can see a little bit better here. Okay, and what are our 3 types of disaccharides? Well, one is sucrose. Okay, remember our monosaccharides were glucose and galactose and fructose. Remember that from that other slide. Glucose, galactose, and fructose were all C6H12O6, but they had different shapes. Well, sucrose is a type of disaccharide that's actually made up of a glucose plus a fructose, and we got to say, minus that H2O, and that's what we get when we get a sucrose. Sucrose is table sugar. Table sugar. It's the stuff that you use in baking your Christmas cookies or sprinkling cinnamon sugar on like Snickerdoodles, which my snickerdoodles turned out really good this time. Sucrose is one. Another one is, and you may have heard of this before, and some of you may not be able to tolerate this, lactose. Lactose is actually a glucose. Notice they all have a glucose in them so far. Plus, this time, galactose. Galactose. And again, minus a water, because sucrose, lactose, and the third one I'm going to talk about, these are all disaccharides. Lactose, that's milk sugar. And when you can't digest lactose, you actually can't break that bond between glucose and galactose. You lack the enzyme. Lack the enzyme for lactose. You can't break that down. Your body would be able to digest glucose and would be able to digest galactose if they were by themselves. But when they're connected, that bond that connects them, that one right there, it's actually called a glycosidic linkage. You don't have to know that word. But you can't break that linkage. And so it spoils in your stomach and it makes you feel sick to your stomach. And lactose intolerance is a real thing. It's not like people are just making this up. Okay. But there is a final one. So glucose plus fructose made sucrose, glucose plus fructose, glucose plus galactose made lactose. And what about if we take glucose and we add another glucose, right? Glucose plus glucose minus a water, right? Then we get this thing called maltose. Oh, I'm forgetting the L in there. Maltose. Maltose is like malt sugar. It's actually, we call it liquor sugar. It's a kind of sugar that's in a lot of hard liquors, like gins and rums and brandies and stuff like that. Not that I'm trying to teach you about that stuff, but it's a sugar. They call it an alcohol sugar. And a lot of times that we use maltose, it doesn't have alcohol in it. It's just usually associated with alcohol. But a lot of times they will use sweeteners. They'll use maltose and they'll say, oh, we're using all natural maltose. Like it's so much better than sucrose. Like, oh, we don't want to use table sugar. That's where like that false advertising. You're going to see where a lot of false advertising is in there. And even high fructose corn syrup, they think it's so bad. It's sugar. Sugar is sugar is sugar is sugar. Whether it's a disaccharide or whether it's a monosaccharide, it's still going to burn up in your body. So you drink high fructose corn syrup, it's just the same as drinking lactose. Like a lot of your milk has a lot of sugar in it. Okay. Believe it or not, milk is high in sugar. Okay. So that's our monomer form. And finally, we get to our polymer form. What is this crazy diagram here? Okay, crazy looking diagram. Well, the polymer obviously is like many, 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 many. So we always say it's many monosaccharides. Monosaccharides. So what would you call many monosaccharides? You'd call that a polysaccharide. Polysaccharides. Now, we have 3 examples of polysaccharides listed here, and you can't quite see them. But this first one here, okay, this first one here is actually starch. Starch is a polysaccharide, many, 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 many sugars in it. So, yes, and starch is found in like bread and pasta, right? Bread, pasta, potatoes. Okay, all those like good starchy things, right? And it's very digestible, very digestible. So when you eat bread and say you're going to a pasta party before a big soccer game or football game, why do you eat pasta? Because you have all this sugar that will slowly feed into your system. It's like you're eating these big chains, right, of sugars like this, right? And you'll get a slow feed. Instead of getting like monosaccharides like, into your body, you get this into your body. My beads are flying everywhere. You get this into your body and it's a slow break off feed. Each one slowly little. And that's why you eat pasta before like a big game, because then you'll have that slow, steady feed. I call the polysaccharides kind of like the dry logs you put on a fire. When you put a dry log, it will burn for a while. Okay, so there's starch. There's also this one. It's a funky sounding name. It's called glycogen, and it's in liver. And it's actually a storage molecule in your liver, Okay, and I'm going to run out of time here really quick, so I'm going to mention the last one, which is cellulose. And cellulose is better known as fiber. It's not digestible. Fiber, not digestible.